Hi everyone, I'm Krishna, and today we're going to talk about computers. Way back in the day, there was no computing, only electronics. Some early electrical engineers hypothesized that if a machine could be made to perform sums, save information in relays, and spit out the result, it could speed up calculations massively. The first computer was created. It was the size of the room, ran hot, and drew monstrous amounts of power. It had a few basic functions and truly blazing clock speeds of, drumroll, 5,000 additions per second. And if you wanted to divide, forget it, it could do 40 a second. For context, modern computers are measured in gigahertz, billions of operations per second. Cut the engineers some slack though, it was 1945, and they were working through World War II. Fast forward a decade or so, and the US realized that this computer thing was actually pretty useful. Companies got their hands on it. But there was a problem. Only one person could use it at once. If your coworker was running a horribly slow program, all you could do was, well, wait. So after a few slow and complicated solutions, Unix was created. It was one of the first real portable operating systems. Its job was simple: run multiple programs at once by quickly switching between them. Computers still do this today. Your apps aren't actually running at the same time. They're just switching so fast that it looks like they are. Now let's jump forward to the moon landing era, a time of huge scientific progress. During this time, UCLA and Stanford sent the first message across the ARPANET, the early version of the internet. Instead of building new wires, they used phone lines. They turned data into sound, sent it down the line, and turned it back to data on the other end. The first message ever sent was low. It was supposed to say login, but the system crashed after 2 letters. As the internet grew, so did the number of users. At first, it was mostly people who trusted each other. They didn't really think the system would be abused. They created systems and protocols for emails, websites, and file sharing. But they didn't consider one thing: hacking. A word synonymous nowadays with a hooded figure sitting behind a computer with green or perhaps blue code flowing down the screen. To understand why early systems had problems, let's use an example. Alice, Bob, Charlie, Daniel, and Eve are locked in 5 different rooms. Their only way to talk is through a mail slot in the door. When Alice writes a note and drops it into the mail slot, identical copies of that note appear in everyone else's room. If anyone sends a message, everyone gets it. Now they've agreed to always write their name and their recipient's name on notes to avoid confusion. If Alice wants to send a book to Bob, she'll write "from Alice to Bob" on her note. When she sends it, Bob will get it, but the others will simply shred the note. It's not to them after all. Now let's say Alice wants to send Bob something important, perhaps her passport, address, or bank account. She fills out the note, "from Alice to Bob," and drops it in the mail slot. But remember, the note appears in the others' rooms too. Normal participants will shred it, but what if Eve's a little bit tight on money and happened to see the bank account number? There's nothing to stop her from just pocketing the note. And that is what's wrong with early internet protocols. Anyone could read their contents. And if that message had to pass through you, maybe you were running the router, you could modify it at will before passing it on. This became a problem, fast. So what was the solution? Cryptography. It involves a lot of math, but in simple terms there are 2 main types: symmetric and asymmetric. Both of these let you scramble messages and then unscramble them later, but they work in different ways. With symmetric cryptography, it's like if you and a friend made up a lock and key system. There's only one key, and anyone without it cannot lock or unlock messages. The key can be duplicated if you have it already. With asymmetric cryptography, it works a little bit differently. Instead of one shared secret, you have 2 parts. One part is used to lock the message, and the other part used to unlock it. Now let's go back to our Alice and Bob example. Alice creates a lockbox and key system, which is asymmetric. The lockbox is unlocked, and the key is hers. Anyone can latch the lockbox shut if they have it, but only she can unlock it after it's been latched shut. She keeps all her keys for herself, pre-unlocks the lockbox, and drops it into the mail slot. Bob finds the unlocked lockbox on his floor, writes a message, picks it up, latches it shut, and drops it back into the mail slot. Even if someone else, like Eve, intercepts the message, they can't read it, because they don't have the key to unlock it. They have an unlocked copy of Alice's lockbox, and they have a locked copy of Alice's lockbox. They do not have Alice's key. Let's scale up our example. What if Alice wants to avoid the hassle of making lockboxes every time Bob sends her a message? Or what if she wants to securely reply to Bob without having Bob make a lockbox? That's where our old friend symmetric cryptography comes in. Alice again mints a lockbox and key, unlocks the lockbox, and drops it into the mail slot. But this time, Bob doesn't just lock a message, but he locks a key for his own symmetric cryptography in the box. Then, when the box goes back to Alice, she unlocks it with her key securely. Now, Alice and Bob have shared their symmetric cryptography key and can now lock and unlock messages with the new shared key. And that's the basic idea behind how asymmetric cryptography secures information. From room-sized machines to devices in your pocket, computers have come a long way, and they're still evolving. So the next time you type something online, remember, there's a whole invisible system working just to make sure your message reaches the right person and only the right person. Who knows what computers will be like in the future? Thank you all for listening. Tune in again in 3020 when you have flying cars and maybe some hyperspace travel.